Welcome to Ask and Learn.
We are given a linear non-homogeneous recurrence relation, and we are asked to find the general form of the particular solution of this non-homogeneous recurrence relation. So the relation is an equals 8an minus 2 minus 16an minus 4 plus f of n. And so we have that the associated linear homogeneous recurrence relation is an equals 8an minus 2 minus 16an minus 4. And this has characteristic equation r to the fourth minus 8r squared plus 16 equals 0. We can factor this as r squared minus 4 squared equals 0, which can be further factored as r minus 2 squared times r plus 2 squared equals 0. And so we have that characteristic roots are -2 with a multiplicity of 2 and +2 with a multiplicity of 2. In part A, we're given that f of n is equal to n cubed. This is the same as n cubed times 1 to the n. We have that 1 is not a characteristic root, so it follows that the particular solution has the general form n cubed is a third degree polynomial. So this is going to be p3 n cubed plus p2 n squared plus p1 n plus p0 times 1 to the n, which is just 1. In part B, we're given that f of n is -2 to the n. We have that -2 is a characteristic root of multiplicity 2. So we have that the general form for the particular solution is 1 is a polynomial. Well, first of all, since -2 is multiplicity 2, we have n squared times, and we have that 1 is a polynomial of degree 0, so this is p0 times a -2 to the n, which can be written as p0 n squared times -2 to the n. In part C, we're given that f of n is equal to n times 2 to the n. Two is a characteristic root of multiplicity 2, and so the general form for a particular solution, well, we have that n is a polynomial of degree 1, so this is going to be n squared times, and then this is p1n plus p0 times 2 to the n, and this can be expanded and written as p0 times n squared times 2 to the n plus p1 times n cubed times 2 to the n. In part D, we're given that f of n is equal to n squared times 4 to the n. 4 is not a characteristic root, and we have that n squared is a polynomial of degree 2. So the general form for a particular solution is p2n squared plus p1n plus p0 times 4 to the n and you can expand this if you want to. In part E, we are given that f of n is n squared minus 2 times negative 2 to the n. We have that n squared minus 2 is a polynomial of degree 2, and negative 2 is a characteristic root with multiplicity of 2. And so the general form for a particular solution is n squared times p2n squared plus p1n plus p0 times negative 2 to the n. And this can be expanded and written as p0 times n squared times negative 2 to the n plus p1 times n cubed times negative 2 to the n plus p2 times n to the fourth times negative 2 to the n. In part F, we're given that f of n is equal to n to the fourth times 2 to the n. We have that n to the fourth is a polynomial of degree 4, and 2 is a characteristic root of multiplicity 2. So the general form for a particular solution is n squared times p4n to the fourth plus p3n cubed plus p2n squared plus p1n plus p0, all times 2 to the n. And this can be expanded, although it's not necessary to do that. But this is also a valid solution. And in part G, we're given that f of n is equal to 2. This is the same as 2 times 1 to the n. We have that 1 is not a characteristic root, and 2 is a polynomial of degree 0. So the general form for a particular solution is simply p0 times 1 to the n, which is just p0.